So for the calculations of this experiment, okay, the numbers that you need is your molarity for the known oxalic acid, your 0.150, what you have in number 3. The volumes that you're using in each sample, which is what I have listed in number 4, you have 4 milliliters of oxalic acid in each sample. Convert those numbers to liters. Okay, we're using molarity as a conversion factor to find out number of moles. So if you're using molarity as a conversion factor, since molarity is moles per liter, right, any volume that you're using to find moles with molarity has to be in liters. Number 5, if it's your initial volume in the V-red. Number 6, it's how much you're using from the permanganate to titrate the sample. To calculate the volume of your permanganate, that's just your final volume minus the initial volume. So for example, in the first one, sample number 1, your final volume is 14.1, your initial volume is 0. So your volume of permanganate will be 14.10 minus 0, which is just 14.10. Now, the tricky part is how to get the molarity of the potassium permanganate. If you're finding molarity of potassium permanganate, you want to use moles of permanganate and volume for potassium permanganate. You cannot find molarity of potassium permanganate using moles of oxalic acid or volume of oxalic acid. Everything that you're using in that equation has to correspond to potassium permanganate. If you have concentration and volume, you can find moles. Okay? Moles is equal to molar concentration times volume in liters. There is something that you can use to find moles. You have molarity for your oxalic acid and you have volume for oxalic acid. What you have in number 3 and number 4. Molarity for oxalic acid is 0.150. Volume for oxalic acid is 4 milliliters. You can convert 4 milliliters to liters by dividing 4 by 1,000, which is going to give you 0.004 liters. So you can get the moles of oxalic acid because you have a concentration and a volume for oxalic acid. You don't have a concentration for potassium permanganate. The concentration that you have listed in number 1 is the concentration for the original solution, the one that you're using to prepare your dilution. That's what you're trying to get, the exact concentration of potassium permanganate. Okay? So we're using what we have for oxalic acid, and then the number of moles of oxalic acid that we're getting, we can convert to moles of potassium permanganate using the stoichiometry from the reaction. So to get the moles of oxalic acid, you're doing what you have in number 3, which is your molarity for oxalic acid, times a volume of oxalic acid, which is what you have in number 4, but that volume has to be in liters. That will give you the moles of oxalic acid, but that's not what you want. You want moles of potassium permanganate. Whatever number of moles of oxalic acid you're getting, times your conversion factor, which is 2 moles of potassium permanganate over 5 moles of your oxalic acid, H2C2O4. So that will be 2 over 5, and this 2 is permanganate, and this one is oxalic acid, O4, sorry, not O3. So you're converting the moles of oxalic acid, which is what you can calculate with concentration of oxalic acid and volume of oxalic acid. You're converting that number of moles to moles of potassium permanganate using the stoichiometry from the reaction. So that number that you're getting when you're multiplying the moles of oxalic acid times 2 divided by 5, that's the number of moles that you need right there in that equation to get the molarity of your potassium permanganate. Now the volume of potassium permanganate, that's what you have in number 7. You're calculating how much potassium permanganate you're using in your titration. So that volume that you have in number 7 in liters, you see how I'm highlighting in green, liters. Whatever number you're calculating, it's in milliliters because the burette, it's measuring volume in milliliters. So you have to convert your milliliters to liters, and that's the volume that you're plugging in your equation in number 8 to get the molarity of the permanganate. So you're doing the same thing with each sample. You're calculating the moles of oxalic acid. The moles of oxalic acid is the same for all 3 samples because the concentration and the volume for oxalic acid is always the same, 0.150, and the volume is 0.0004, okay, 0.004, 2 zeros. So the number of moles of oxalic acid is not changing, which means that the number of moles of potassium permanganate that you're calculating will be the same for all 3 samples. What is different in each sample is the volume of your potassium permanganate, because you have a volume in your first sample, another volume in the second one, and another volume in the third one. So you're calculating the molarity for your 3 samples for potassium permanganate, and then number 9, you have to get the average. So you add the number that you're getting for the molarity of potassium permanganate in sample 1 plus what you have in sample 2 plus what you have in sample 3, all 3 together, and then divide by 3 to get the average. Now the calculations for the unknown solution are very similar. Now the difference for this part is that the number of moles that you are going to determine is the moles of potassium permanganate because you don't know the concentration of oxalic acid. That's what you're trying to find out, molarity of oxalic acid. So in this one here, to get the moles of potassium permanganate, you're doing your average, which is what you have in number 9, the average concentration for potassium permanganate times the volume of potassium permanganate. Remember, if you want moles of potassium permanganate, you need concentration for potassium permanganate and a volume for potassium permanganate. The volume for potassium permanganate is what you have in number 13, liters. Remember, number 9 is molarity, which is moles per liter, times a volume in liters. Your unit of liters is canceling out and you're getting a number that is just moles. So those are your moles of potassium permanganate. Now the moles of potassium permanganate you have to convert to moles of your oxalic acid. Since what you want is oxalic acid, now you have 5 moles of oxalic acid over 2 moles of potassium permanganate. So those are the moles for your oxalic acid, which is what you need in this equation to calculate the molarity for your oxalic acid. So you have to do the same for all 3 samples. For sample 2, you have to find out the moles of the permanganate first, which is the average that you have for potassium permanganate in number 9, times the volume that you have in sample 2 for potassium permanganate in liters, And then you have to convert those to moles of oxalic acid using your stoichiometry from the reaction. In this case, is 5/2 because 5 is the coefficient for your oxalic acid, and that's the one that you're trying to calculate. And that will be divided by the volume in liters of oxalic acid. The volume in liters for oxalic acid, that number right there, is what you have in number 10 in liters. Number 10 is the volume of your sample. You're using 4 milliliters in each sample. So convert that number to liters, and that's the volume that you need to calculate the molarity of oxalic acid. You're doing the same thing for all 3 samples, and then you can calculate your average concentration, adding the molarity for your oxalic acid in sample 1 plus the molarity of oxalic acid in sample 2 plus what you have in sample 3, all divided by 3. That will give you the concentration of your unknown solution of oxalic acid.